So we are going to work on this question in which we have to just find a linear relationship. So it's given that atmospheric pressure at the sea level at some point is 101.3 kilopascals, and at 3,000 feet above the sea level is 90.8 kilopascals. And we have to write this, actually, this should be P. So we have to find a linear relationship between P and X, where X is the altitude for this range 0 to 2000 by using this. Okay, so notice this, when X is 0, what we have is we have P equals 101.3 kPa, right? So what does it mean? It means this, that we, if X is 0, okay, then P is 101.3, right? Okay, which gives us what? Which gives us that B equals 101.3, right? So we get this much now, that P equals mx plus 101.3, the p-intercept, if you recall the equation formally. Now it's given that when x is 3000, okay, so let's write x as 3000, then at that time, at that height rather, our p is 90.8 kilopascals. So what would this give us? This is, so we substitute that in here, an equation that we have already simplified. So this is 90.8, all right. And x is how much? X is 3000, right? So we get, what do we get? Our 3000 m will be 90.8, right, minus 101.3, okay, and that becomes 3000 m is, let's take that difference. Now, you know, this line, this linear relationship has a negative slope, okay, so this is how much? That difference is negative 10.5. So m is going to be negative 10.5 divided by 3000. All right. So let's just, let's just write this relationship purely like this, and we can, or we can just change it to decimals if we want. Okay, so we have, one moment, we got this. So the answer is that, okay, all right. So we have this for our linear relationship, right? And then let me move this up here because this is still within our recording window, all right? So it says find the pressure at an altitude of 2000 feet. So all that I have to do is that just substitute 2000 in here and let the calculator calculate it. So that's going to be how much? 94.3, and let's just write the unit here, kilopascals. Now it's asking for this. It gives you the altitude as 96, sorry, the pressure as 96 kilopascals and want you to calculate the value of x. That is what the altitude is. Okay, so, well, this will be a similar kind of question. So this is this. So if the pressure is 96 units, then that means we have to solve this equation. Okay, so what we would do is we will keep x on one side and move everything else on the other side. So let's do this. I hope doesn't look too complicated to you. I'm moving it to the left. That means the negative sign would be the positive sign, and moving 96 to the right? So what do we get that way is that this quantity, I've been lazy, I didn't even try solving that quantity. So 101.3 minus 6 would be how much? 5.3, am I right? And so when we try to get x, we can multiply by 3000 and get x and get 10.5x as how much? 5.3 times 3000, right? And then all that we have to do is here to obtain my x is to divide this by 10.5, right? That will isolate x for us. So we got this. So let's take this expression, divide by 10.5, okay? And then what we get is, we get about 1514 feet according to this equation. So that's the altitude at which the pressure is 96 kilopascals. Now, if we have to graph it, we can go to Desmos or some other, or some other graphing utility and just enter this expression, and that will graph the line for us. Okay. All right. Now, just one more little point, just for information, that I got this from this website. Okay, and what you have is that, like, once you get to higher and higher altitudes, the relationship between the elevation, here it's in meters actually, so the elevation above the sea level and the atmospheric pressure, it does not go down linearly, all right? And since we were doing just the linear relationship at that time, we did not take, this further into account, but keep that in mind, that that linear relationship does not really hold for long, okay?